Okay, maybe let's talk about a couple of these. So the derivative spits out the slope of the tangent line at a certain point. In this question here, what they want us to do is estimate the slope of the tangent line here at -3. So tangent means we just come in and we're just parallel to the line at that particular point. So I have to just kind of eyeball this and kind of extend it out. My tangent line would come in like this. That looks like it's a slope of, let's see, I went down 1 and over 2, about -0.5. And there's some wiggle room here because we're just estimating. So it's about -0.5. And hey, I got it right. That's what we're looking for there. If we're going to do a definition, let's do a more complicated one. Here, it's asking you to list all the x values where we have horizontal tangents. That's where the derivative would be 0. Those happen at local maxes and local mins, local extrema. So at the tops of hills and the bottoms of valleys. So right there, we would have a horizontal tangent line. And right here. And we're asking for those x values. Anytime somebody's asking you for the slope of the tangent line, they're asking for the derivative at that point. And here, see, I mentioned this a few minutes ago. The homework system wants you to put your line, when you find the equation of a tangent line, in slope-intercept form. On anything written, I'm always okay with point slope form. I was playing around with this one, and my answer is still on there. Here, what they're asking us to do is use a table to estimate a derivative. Now, in the real world, what you would do would be this. You would find the average rate of change on both the top end and the bottom end, and then you would average them together. But this has enough wiggle room that what we would do here is just find the average rate of change between these 2 points. So I'm at 1.2. So I would do change in y divided by change in x. So final minus initial over final minus initial. And again, in the real world, what you would do, that would be the derivative above 1.2. We would also do from below final minus initial divided by final minus initial, and then probably average those two together. But here we can, I think there's enough wiggle room here. I've never seen that in the code before. Whoever wrote this question, I think they've edited it. I don't know what the system does when the answer says near. I don't know what the coding does there. So you could say I was trying different values to see how close I could get and still get credit. There's some wiggle room there. Definitely make sure you not do this problem. That's a good one. This question here always causes trouble. This is a piecewise defined function. So my suggestion to you would probably be to graph it out or write out the definition itself. Remember piecewise from college algebra. So up until 6, so t of, what's my independent variable here? X. T of x is going to be a piecewise function. And if x is less than or equal to 6, I believe it was. No, just less than 6. Tuition is a constant, $4,000. Trying to move my screen here, so I'll just keep going back and forth. From 6 to 14, including both of them, were $5,000. And then here's the tricky part, this next one. That's an X there. $5,000 plus $100 per credit for credits over 14. So it's not this, it's not 5,000 plus X for X bigger than 14. Because if I plug in, say, 15 left off of my 100, it's not this. If I plug in X equals 15, I don't want 15 times 100. I get charged $100 per credit over 15. So I need to subtract over. I keep getting my 14s and my 15s. Over 14, $100 per credit over 14. So if I take 20 credits, I'm only paying the $100 on 6 credits, 15 through 20. So this is my function. And we could graph that. So up until 6, it's a constant at 4,000. Up until 14, it's a constant at 5,000 between 6 and 14. And then we're going to have this shifted graph that starts at 5,000, so it's continuous at that point and goes up with the slope of 100. So at that point, it's continuous. It's not continuous here. Remember, for the derivative to exist, the function must be continuous and smooth. Continuity is not enough for the derivative to exist. Okay, based on all that, you should be able to get through the homework question. Okay, these are all good questions. Let's do one more definition of the derivative. Okay, so I don't know, maybe we'll do this one here. 25x plus 7. It's kind of a boring one, but we'll do it. So f of x is 25x plus 7, and I want f prime of 3. Now, I have two choices. I could find the derivative as a function. I could find f prime of x and then plug in 3. Or I could use the limit definition at a point and just answer the question that I was asked. So, I don't know, maybe for fun, we'll do it both ways. Do I have time? I really don't. Okay, so this, if we're just doing it at a point, would be the limit as h approaches 0 of f of 3 plus h minus f of 3. You need to have this definition memorized. As h approaches 0. F of 3 plus h means rewrite the entire function, but now instead of writing x, we're going to write 3 plus h in parentheses. Notice I rewrote the entire function. That's just this. Minus. Now I'm going to rewrite the entire thing in parentheses, but instead of writing x, I'm going to write 3. And that's all over h. Don't forget you're over h. A lot of mistakes happen there. All right, now I got to clean this up. Don't forget you got to write limit as h goes to 0 at every step. What do we get? 75 plus 25h plus 7 minus 75 minus 7 all over h. Everything over here is always going to cancel out. Well, at least with polynomials. And I get 25, limit. See, I almost goofed there. Got to write the limit. As h goes to 0 of 25h over h. The h's cancel. Now I can actually take the limit. Limit of a constant is just a constant. Like I said, this is a boring problem. Limit as h goes to 0 of 25 is just 25. We're done. This functions derivative at 3 is 25. Of course it is. This is a line. His slope is 25. His derivative everywhere is 25. All of his tangent lines are the line itself, and his slope is 25. Okay, I got another class at noon. I'm going to have to stop there. Yeah, on Thursday, we'll do some more review for test 1, I think. All right, any quick questions before I stop? All right, have a good day.